what is an eigenvalue problem? If a matrix, if A n by n is a matrix, comma x n by 1 is a column vector or a column matrix such that column matrix of unknowns, actually, unknown parameters, such that A times x is equal to lambda times x, where lambda is a scalar. Okay, then this Ax is equal to lambda x is called as the eigenvalue problem. This is called as the eigenvalue problem. Now, what is the solution? Solution is to find values of lambda and corresponding vectors x which satisfy this equation. Okay, Ax is equal to lambda x. All right, so you must have done this problem in your classes and in your mathematics classes. Can anybody tell what are the applications of this? Before we begin on that, this lambda, values of lambda are called as values of lambda are called what? Eigenvalues or characteristic values. And the vectors x are called eigenvectors or characteristic vectors. Okay, now where are the applications of this problem? LCR circuits in basic electrical engineering. So when you try to solve that problem of current, you get it's an eigenvalue problem. Problems of vibrations in structural engineering, structural vibration or mechanical vibrations, they involve solving this eigenvalue problem. And very interestingly, the Google search engine that we so commonly use every day, all right, Google search engine searches the input parameters that we put in there. It converts it into an eigenvalue problem and solves, and it gives that solution in 1 second. The sequence in which you get the searched options are based on the descending order of the eigenvalues. So there are a lot of applications of this, and that is why it is included in engineering mathematics syllabus. So how to solve? So this is the eigenvalue problem. Now how to solve this eigenvalue problem? So we form what is called as the characteristic equation. So given eigenvalue problem is A into X is equal to lambda times X. Now we write this as A into X minus lambda X is equal to 0. Now we know that the first term here, A into X, is n by n into n by 1 matrix. So it is n by 1 vector, and this is lambda into n by 1 vector. Okay, so it is n by 1 vector both. Now what I'll do, I will write this as lambda times I times X, where I is nth order. I is nth order identity matrix. Okay, so what do we get now? We can now take X outside. All right, now we get A minus lambda I, A minus lambda I into X equal to 0. Now this is solution to homogeneous linear equations. Okay, this equation. This equation is an homogeneous system of linear equations. This is an homogeneous system of linear equations. Correct? Now, this has a trivial solution. The equation has a trivial solution if determinant of A minus lambda I is not equal to 0. What is the trivial solution? Okay. What is the trivial solution? The trivial solution for a homogeneous equation. What is it? Anybody? It is X equal to 0. For a homogeneous equation, X is set of unknowns, X1, X2, X3, let's say. The trivial solution is all of them are zeros. Then automatically this will be 0. The trivial solution X equal to 0 is not of interest to us, because we cannot find, then lambda can be anything, doesn't make a difference. We are interested when do we have solutions other than X equal to 0. To obtain non-trivial solution, determinant of A minus lambda I equal to 0, this is equal to 0. Sorry. Determinant for a non-trivial solution, determinant should be equal to 0. And this determinant A minus lambda I equal to 0 is called as the characteristic equation of the matrix. Characteristic equation of the matrix A. This is called as the characteristic equation. And you can observe this determinant of A minus lambda I. A will have some values. I is identity matrix. So lambda into I will be a diagonal matrix with all the diagonals as lambda. A minus lambda will give you in A all the diagonals elements will be subtracted with lambda. When you take a determinant of this, you will get an equation minus 1 to the power n lambda n plus some constants c1 into lambda n minus, oh, sorry, not lambda n, lambda power n, and c1 into lambda to the power n minus 1 plus c2 into lambda to the power n minus 2, so on, plus cn. This will be equal to 0. So characteristic equation, the characteristic equation is a polynomial of nth degree in lambda. So a polynomial in nth degree of lambda, how many solutions will it have? How many solutions will a polynomial of nth degree have? Answer?
N solutions.
N solutions. Very good. It can be real or imaginary. Okay. Characteristic equation is a polynomial of n degree in lambda, which can have a maximum of n real roots. Real roots in lambda. Now it depends on the problem. The lambda, the roots can be real or complex. So therefore note, important, note, a matrix of nth order can have a maximum of n eigenvalues, because values of lambda are eigenvalues. Okay, so a matrix of order n can have n eigenvalues. All right. Now if n is odd, then if n is odd, then the matrix will have, for an odd degree polynomial, how many real roots will be there? Complex roots occur in conjugate pairs. So if complex roots exist, they will be even in number. Complex roots will be even in number. Okay. So suppose n is odd. So maximum, let's say more practically all the roots are complex. So you will get n minus 1 will be even. Those many will be complex roots. There will be one real root. One real root. For if n is odd, then the matrix will have a minimum of one real root. Okay. And a maximum of n real roots. So one real eigenvalue, one real eigenvalue, and a maximum of n real eigenvalues. So these are objective questions which you will get in GATE based on this. So when you solve this characteristic equation, you will get the eigenvalues, and based on that we can find the eigenvectors.